Today we are starting with our age level physics topical lectures with the first lecture over there, physical quantities and units. Physical quantities, before going to words, I will introduce towards physics. Physics, what is physics basically? We can say branch of science which deals with mass, energy. Mass can be taken as matter, energy, and a relationship between them. Relationship between them can be taken into account. And if I go for explanation of matter a little bit, like everything which has mass and occupies space is called matter over there. We can say everything which has mass and occupies space is called matter. And energy is, we can say energy, ability of body to do work, ability of body to do work. And energy is a scalar quantity. Matter, mass is also scalar quantity over there. Like they don't have any direction. Energy is measured in joules, and mass or matter is measured in kilograms. If I move towards the basic units of or basic quantities, then according to international system international of units and quantities and units over there, we have basic 7 units over there, base quantities over there, base quantities, all measurable quantities, label quantities are called base quantities. According to System International 1940 in Paris, Weights and Measure Conference, System International was introduced, in which 7 base quantities were introduced. That was length, that was mass, that was time, that was also related length, mass, time. After that, temperature. After that, there was amount of substance. Substance. And there was intensity of light, and or luminous intensity, we can also say like that. After that, luminous intensity means the source should give out the light intensity over there. After that, if I go for after luminous intensity, I will say there is electric current. These were the base 7 units. And if I count them like that, 1, 2, 3, 4, 5, 6, and 7 over there. Okay. Length was measured with its SI base unit in the form of meter m. Mass was measured in unit kilogram. Time was measured in seconds. Temperature was measured in Kelvin in SI base units over there. Amounts of substance was measured in mole. And if you remove E, that is its unit. If you name it, then MOLE. After that, intensity of light was given with the help of candela. Electric current was measured in amperes over there. If I go more in detail, then I will say length will be measured by meter rule. Measuring tape. Vernier calipers. etc over there, screw gauge, and for mass, it was having physical balance. It was having electronic balance over there. So, and that was the standard of mass to measure in kilograms over there. After that, time was measured with the help of digital and analog stopwatch to measure the interval, to measure the interval of an event, to measure the interval of an event over there. Like some athlete is starting his race over there, stopwatch is started, and when he crosses the final line, or then it is stopped and time is being measured with the help of stopwatch. So time is measured in seconds over there with its basic unit. Temperature is measured in Kelvin in calculations. It can also having the other scales like degree centigrade, like Fahrenheit scale. Degree centigrade is used in laboratory thermometer. Fahrenheit scale is being used in, we can say, clinical thermometers over there. And if I go to the interconvergence of both of them, then I know temperature in Kelvin will be calculated as temperature in degree centigrade plus 273. And if I take Fahrenheit temperature to want to calculate over there, then I will take 1.8 degrees centigrade plus 32 over there. So this is the basic phenomenon behind both of these formulas, that interconversion of temperatures should be taken into account. But in calculations, when you are going to do the calculation related to physics numericals over there, you are going to use temperature in Kelvin over there. After that, amount of substance is related to mole over there. And 1 mole substance is basically related to Avogadro's number. If some substance is present with 6.022 multiplied 10 raised to power 23 atoms, molecules, ions, like that, having these numbers of their ions, molecules, atoms over there, then amount of substance will be 1 mole towards that. Amount of intensity is luminous intensity, like any source which is giving light out, that is measured in candela with standard candles over there, intensity. In A2 physics, we will study about astronomy and cosmology, and we will explain about luminous intensity, luminous sources and non-luminous sources over there. After that, electric current is measured in amperes using the device ammeter. And it is a rate of flow of charges that is connected in series and having very small internal resistance. And more later on, these examples and these explanations will be done the electricity chapter, which is included in this syllabus over there. On the basis of these base quantities and base units over there, we have to move towards derived quantities. Derived quantities are those which are derived from base quantities. For that purpose, I will simply say here derived quantities are being taken into account. For example, you are taking speed. Speed is basically, according to its formula, distance over time. And distance is just like a length. Then it means it is meter over time is second. Then its unit will be giving you meter per second over there. For velocity, the same case, displacement will also measured in meters and time will be taken into account. If I go for acceleration, I know that it is a change in velocity with respect to time over there. So velocity or speed is having unit ms minus 1 and s is down. I'm taking it ms minus 2. If he's saying to me go towards the force, then I know its formula is according to Newton's second law, that is mass into acceleration. Mass, I know that unit is kilogram, and acceleration I have just calculated, that is meter per second square, is having this one. For this one, we will also have the work unit over there. That is force multiplied distance. And above one, you have the force unit over there in SI based units. I'm not talking about like forces having the unit Newton over there, work is having unit Joule over there. But in base quantities or base units, I will have to deal only with kilogram, meter, second, Kelvin, ampere, only with these one over there. So kg meter per second square is also going with for force. And then later on for distance is meter. So my unit is kg meter square per second square. So for work, I am going for it. Now I am moving towards pressure. I know that it is force over area. If I take like this, then I will say force is having unit kg meter per second square, meter per second square, and area is length multiply length means meter square over there. 1 meter is gone from here. Then I am having the unit kg m minus 1 s minus 2. So this is the way how I can calculate the pressure. This is basic, its unit is Pascal. It can also be taken as stress over there on the elastic object over there, stress. And also for the Young's modulus, which will be taken into the form of stress and strain ratio is equal to change in length, and strain is basically ratio between change in length and original length. So that is having no unit in that case. So this is the way how to go for derived quantities to work with. And if I move little bit example related to this, I'm taking some questions from here so that according to examination point of view, how they are going to work over there. I'm taking little bit examples over here and how to manipulate these units into our sections. I will also add these questions over there. And so that your concept related to exam questions can be easily explained over there. These some questions I have taken from past papers over there so that your concepts can be more clarified related to derivation of these MCQs over there. Like he is saying here, he is saying over here, like in this question, the SI unit of heat capacity is joule per kg per Kelvin. What is the specific heat capacity expressed in SI base unit? So I will have to remove this joule from here. And then after that, I will simplify it and get some answer from here. So it is given as joule per kg per Kelvin. Per kg per Kelvin is fine in their base units, but joule is not in base units. So for joule, I am taking here that is work unit. So F dot D with kg minus 1, Kelvin minus 1. F I know kg meter square, S minus 2 dot meter. After that, this is for work kg meter per second square for force, and S is for distance for work over there, kg inverse, Kelvin inverse. If I look here, then I know that kg is gone with the kg and meter square is still there. So it is meter square because this meter and this meter are being multiplied and base m powers added. S minus 2, K minus 1. M square S minus 2, M square S minus 2, K minus 1 is going for this MCQs to be right over there. After that, little bit move to next question over there. What is the unit of Young's modulus in SI base unit? As I told you, it is just like a pressure. Young's modulus is equal to stress over strain. If I go for its calculation over there, then I will say here, stress is force over area and strain is change in length over original length. So this is meter cancelled out. Only I have the above one, that is kg meter per second square over meter square. So 1 meter is gone from here, 1 meter. It is kg m minus 1 kg m minus 1 s minus 2 over there is the right answer for this one. Let's go to the next question over there where he is explaining about the Reynolds number R is a constant is used to study the liquids flowing through the pipes. R is the pure number with no unit, means R is having no unit here. R is having no unit. And where rho is the density of the liquid, V is the speed of the liquid, and D is diameter of the pipe liquid flows. What is the unit for mu? So I am making mu as subject over there. So mu is coming here in place of R because R is having no unit. So I'm not writing it here. Rho V with diameter D. And I know the density is having unit kilogram per meter cube. Speed is having unit meter per second. After that, diameter is also having its unit meter because that is also a length. So it is kg. Meter minus 3 plus 1 minus 1 s minus 1 m minus 1 s minus 1 kg. So it is the right option for it. After that, he is saying the time taken for a satellite to orbit the Earth on a circular path is given by equation this t square kr cube over m, where r is the radius. Okay, r is the radius, and m is the mass of the Earth, and k is a constant. What are the SI base units for k? I may have to make this k as a subject. So k is equal to mt square over r cube. So m is having unit kg, t is having unit s square, r is meter cube, so it is coming up m minus 3. So m minus 3, s minus 2, kg minus 1, no. Kg m minus 3, s power 2. So it is the right option. So try to focus and try to find your unit by calculating by if the square is there, then take second square. If meter is there having power 3, take its cube also, and try to simplify that question also. And what is the unit of the weight in terms of SI base unit? Weight is just like a force. W is equal to mg, and m is having its unit as kg, and g is having its unit as acceleration ms minus 2. So it is kg meter per second square over there. So this is the right option for that. As the temperature close to 0 Kelvin, the specific heat capacity C of a particular is given that C is equal to BT cube, where T is the thermodynamic temperature and B is a constant characteristic of a solid. The SI base unit of specific heat capacity is joule per kg per Kelvin. Okay. Uh, what is the base unit for B over there? It means C is giving its unit over there, and I will have to simplify it. No problem, we can do it. First of all, I will have to make B as a subject. It is C over T cube is equal to B. C is it's having its unit joule, means F dot T means kg meter per second square with 1 meter. That is for joule. After that, per kg per Kelvin over Kelvin cube. So I am taking here kg cancel, and no need to write it. Kg are cancelled. So I'm not writing here kg over there. And now what I have, meter square, s minus 2, and k plus 3 is coming up with k minus 4. So meter square s minus 2 with Kelvin minus 4 is the SI base unit. So don't worry about the units. Just apply the formula, apply the basic units which you know about the base quantities over there. It can easily be handled out. After that, I will say here some prefixes you should memorize. Prefixes. 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 are the words or letters added before SI units, like in the form of, I'm taking here with hexa, theta, tera, mega, giga, kilo, hecto, deca. After that, I'm going back, deci, centi, after that, milli, after that, micro, nano, pico, femto, and atto. So hexa is basically we take here hexa 10 raised to power 18, peta 10 raised to power 15, tera 10 raised to power 12, mega 10 raised to power 6, giga 10 raised to power 9. No, mega and giga. Oh, I have changed the sequence, no problem. 9 and kilo 10 raised to power 3, hecto 10 raised to power 2, deca 10 raised to power 1, deci 10 raised to power minus 1, centi 10 raised to power minus 2, milli 10 raised to power minus 3, micro 10 raised to power minus 6, nano 10 raised to power minus 9, pico 10 raised to power minus 12, femto 10 raised to power minus 15, and atto 10 raised to power minus 18, like that. So these are the words or letters which are added before SI units to show you that for very largest quantities or very smallest quantities like virus size or like that, or mass of earth over there to be expanding over there, then we use for very largest quantities and very smallest quantities, we use these prefixes to show their distances over there and to show their size over there easily in understandable formation. And what more I should tell you about the units? You will have to go for estimations also. And those estimations, like what is the mass of pencil, what is the mass of, means how much I can approximate that. I can say that it is 50 gram for a lead pencil over there. Then I can say what is the height of a human, that is 1.2 meter, like that. Should be taking into account. It's an estimation over there, and the basics which you have learned, that standard form notation, scientific notation, to write the different quantities will be taking into account. So this was your class related to physical quantities of ACE Physics. I think so you have got what we should learn about the physical quantities and how should we implement them into the past papers by the basic derivations over there. And in the next class, we will move towards the uncertainty in principle. That is, I think so, we have already uploaded for you on YouTube channel. And kindly subscribe my channel, and so that next lectures, when they are going to be uploaded, you can easily access them and get the notification of that topic over there. And before October, November exams, all the lectures will be uploaded and yearly papers will be done for you. Thank you so much for today. Allah Hafiz.